Welcome everybody to the Practical Data Lunch and Learn. So we do these every so often, and we bring on pretty awesome guests like Brian here from Cube, and we're going to talk today about semantic layers. What is a semantic layer? I think for context, we had a group discussion about this many months ago, and I think it left a lot of questions. And so hopefully Brian will be able to illuminate us and in the world with what a semantic layer is and probably is not. So anyway, Brian, I'll let you introduce yourself and get going. So.
Sure. Yeah. Hey, thanks, Joe. Yeah, I'm going to try real hard today to explain what a semantic layer is, but it's kind of a funny topic. I think there are a lot of companies that call themselves semantic layers or build things that they go to market with semantic layers, the term, that are very different. So when I dive into the slides, we're gonna talk about that. So if you are confused, don't feel bad. It's a very confusing market. So I'm gonna help hopefully clarify a little bit of it. But I'm gonna go ahead and get the sharing going, and let's see what I've got here.
And do you want to take questions at the end, or do you more prefer to interact with the group as you go along?
You know what? I can interact as we're going along. I've got about 25 slides. I guess just for housekeeping's sake, I'll say that Tony Kaw is joining me today. Tony's a partner solution architect at Cube. He's going to be trying to monitor the chat. So if you have a question and it's in the chat and I don't see it because I'm presenting and I'm not looking at the chat so much, don't feel bad. But yeah, if you want to come off mute and ask something, yeah, go ahead and I'll do my best to answer it. Cool. Well, yeah, so Joe, thanks for having me. Everybody, nice to be here. Great to be with you today. Yeah, let's get into it. I'm going to talk about semantic layers. And who I am, my name is Brian Bickell, VP of Strategy and Alliances at a company called Cube. Cube is a purveyor of a universal semantic layer software. That's me, brian.bickell@cube.dev. Drop me an email. I'm easy to find. A little bit about my background. Before this job, I've been here at Cube about 3 years now. Ran tech alliances at a company called Firebolt for a little while. And then before that, I spent 15 years in a consulting firm doing everything from web development to data engineering to business intelligence. And that company was a company called Interworks that became oddly famous for doing Tableau and Alteryx work, and then eventually Snowflake work. So yeah, I have a background as a practitioner. I'm going to tell you, I haven't been such a hands-on practitioner in maybe the last 3 years or so. I'm hoping to get back to more of that in my spare time. But right now I'm at Cube doing all things GTM and alliances. So I am going to try to keep this talk fairly agnostic as far as which semantic layer we talk about. But do keep in mind, I'm going to have a couple Cube slides in here just because, we have to explain what semantic layers are. But I'm going to do my best to give you guys a pretty general overview. And I certainly don't intend to try to sell you anything. I don't carry a sales number. I don't care if you buy software. But if you do, I hope you know what you're buying. So with that out of the way, let's talk about the agenda. Yeah, first and foremost, what is a semantic layer? What problems do they solve? And then a section that I like to call, yeah, but you can do that with X. And X is a lot of things. People all the time object to semantic layers saying, yeah, but you can solve that problem some other way. So I want to talk through some of those. Let's talk about where semantic layers came from, maybe why you keep hearing about them so much. Why are we talking about them? Where are they going? And then finally, the $1 million question or $100,000 question or whatever your contract size is. Do you need a semantic layer? That's the let's call it the $100,000 question. Maybe you'll leave this thinking you do. Maybe you'll leave this thinking you don't. First off, what is a semantic layer anyway? Well, semantic layer is sort of a weird piece of software. And, when I knew I had this talk coming up, I thought, how do I explain what a semantic layer is and what it isn't? And what visual metaphor can I use? And I kind of settled on the platypus, which, if you know about platypus, the first time we discovered a platypus, people sort of thought this was a joke creature. The people who taxidermied one for the first time and kind of brought it back to the civilized world, everybody thought this was a prank, right? Like, this is just a bunch of crap stuck together. This is not a real animal. And in a way, semantic layer and a platypus is a pretty decent metaphor, because semantic layers are really a couple different technologies kind of crammed in the same box to solve some problems. We have the database connectivity aspects of a BI tool. We have the data modeling aspects of BI tools. We have API endpoint aspects of something like a fast API or any other API gateway that you might use for web development. We do things like caching and pre-aggregation, which obviously, if you're coming from web dev or DevOps, you might grab something like a Redis or a Memcache for. You might think, hey, I can use a high performance OLAP system like ClickHouse to do that instead. Or, why not just use Snowflake's materialized views, which are quite good. Or even something like a Dremio to do that. Security and governance, of course, everybody has security and governance across the board, but it's really important to a semantic layer. The thing that I think is uniquely semantic layer, though, really sort of what I think you have to do this if you are a semantic layer, is what I'm going to describe as query rewriting. And query rewriting, if you're unfamiliar with it, is sort of like this this fundamental idea of I am receiving a query via one of these API endpoints. I'm probably rewriting it into an internal representation, and then I'm proxying it or querying it down to a number of different databases we connect to. So most semantic layers connect to a lot of databases, and because of that, they also connect to a lot of front-end tools. And so that rewriting and going back and forth of, how do I get from this API representation to Postgres or to ClickHouse or to Snowflake? That's non-trivial work. I'll say it that way. It's actually quite complicated. Why do we do that? Why does this platypus exist? And what is the main use case? Well, the most sort of well understood or easy use case is simply trying to help consumers that have multiple BI tools or visualization tools or spreadsheets or front ends of any kind that are displaying visual representations or text representations of metrics, help them get the same number in the same place. So this is a graphic that we use quite often to illustrate the concept. Working sort of left to right, you've got the visual representation of a cube data model in our product. This is the same visual model or the same model represented within Power BI, within Excel, within Tableau. So that's the general idea of what most semantic layers are trying to do, or at least maybe the most prominent use case. The tricky part about this is, if you kind of know these platforms, you'll know that you're probably going to speak to Tableau via SQL, potentially via ODBC or JDBC, but SQL of some kind. If you're going to do first-class support for Excel, you're actually not speaking ODBC or SQL. You're going to want to speak MDX, which is a pain in the neck legacy Microsoft language if you're unfamiliar with it. And finally, if you're going to connect to Power BI, you're probably going to speak DAX if you want to do that in a first-class way. So that's one of the problems of semantic layers, and what makes them tricky to build is that they not only support SQL representations of data as their API endpoints, but they tend to have many other languages that they support or ways that you can get at that data. Before I move on, I do want to present one more slide on Cube, because I'm going to talk about semantic layers as we build them. And then this diagram sort of helps you kind of think about what characteristics are typically in any semantic layer you look at, but they all exist in Cube for sure. They exist to differing degrees or various levels of support in many semantic layers. But before I kind of get through this slide, are there any questions? I've seen a couple questions in the chat. I've seen some shit posts in the chat, which I approve of course. But yeah, if you guys have any questions about the talk so far, happy to answer those.
Yeah, I mean, I would say I've been familiar with semantic layers going back to business objects and the concept of universes. So have you seen like an evolution of how we define semantic layers, or is it kind of the same thought process we've had for the past 20 plus years? It's just the implementation of it has differed, or the use cases may have differed in terms of like agents, AI, and things like that?
Yeah, that's a great question. So I do have a history section, and I would give you bonus points because my talk does start at business objects for the history portion. But yeah, that's generally where we think of prior art being. I would say, to kind of shortcut that, the biggest evolution maybe in the last 5 to 10 years with semantic layers has been this idea of being a universal semantic layer. Most semantic layers that we've seen really are attached to a single data warehouse or a single database or a single BI platform. Prior art with that line of thinking is, actually analysis services. SQL Server analysis services is a semantic layer, right? That's an OLAP cubing technology that was tied to SQL Server. I would call that a semantic layer. Looker and LookML, quite famous semantic layer, very close to its ecosystem and tied to Looker. But when I say universal, and that's actually a good segue to this slide, you can kind of look at the left of this diagram. Modern semantic layers are asked to connect to many databases. This is kind of the highlights reel of what Cube can connect to, and these do represent the most common data sources, as you expect, cloud data platforms. However, we have a long list of connectors for the front end of this diagram. Cube supports something like 40 databases. That goes all the way back to things like Vertica, lots of shades of Oracle, Postgres, MySQL, some strange things like Pinot. I used to be at Firebolt, so we built the Firebolt driver. Shout outs to anybody still using Firebolt. Yeah, that's very hard. It's kind of like a problem where you've got to maintain a lot of that ability to translate into those dialects. And then on the front end of things, we support use cases around embedded analytics via a REST API and via a GraphQL API. We support use cases on BI tools and spreadsheets via, again, SQL, which we talked about, MDX and DAX. So that's 5 API endpoints right there. And then I think what's really changed in like the last maybe 2 years, we'll say, has been really people starting to take a look at the idea of semantics and semantic layers and what we would call semantic SQL, and I'll talk about it later in the talk, as a way to take some of the like highly non-deterministic part of AI, of it interacting with databases, and try to give the AI a little bit easier handle on business metrics and concepts rather than just trusting that like Claude or OpenAI is going to figure out exactly, how you would calculate average revenue per user or, any other metric in your business, like what fields it needs to use, what filters it might need to apply, why the data is screwy because you did some weird M&A and like data before a certain date doesn't make sense. All those things that we all have to deal with as data professionals. Hopefully that gave you an answer, but that does get me most of the way through this slide. The other big things in the box with any semantic layer are going to be data modeling concepts. In Cube specifically, our data modeling is in YAML. It's also in JavaScript. It's all code-based, very easy to version control. A lot of semantic layer platforms are this way. If you look at DBT Labs offering, obviously they've got their sort of heavily YAML-based templating language there. So that's pretty common. AtScale is going this direction. AtScale has historically been like a visual editor for their models, but they're getting into more code-based modeling. And that data modeling is really at like a higher level of abstraction. You're usually modeling your data to some kind of entity, which we're going to talk about a little bit later. And then the query rewriting under the hood is simply working with that entity where you might just select dimension or measure from some kind of concept like sales, and then there will be a translation to all of the very ugly joins or subqueries or whatever needs to happen to get that correct result back. Most semantic layers have concepts for access control because a lot of them either connect to many databases that have varying degrees of support for things like RBAC or things like column level masking or things like member level filtering. And also some semantic layers are actually able to join across multiple databases. So in Cube, we can do something that we call a roll-up join, where I could maybe potentially pull a cube out of Redshift and then join it to another one out of Snowflake. We would actually do that in our own caching engine, which kind of gets me to the next part of the slide here. A lot of semantic layers do have caching as a part of the product. In that way, back to sort of the platypus metaphor, they somewhat occasionally look like data federation tools. It's not crazy to start to compare modern semantic layers to something like Denodo. We see that comparison a lot, actually. For us, we built a caching technology on top of Data Fusion that we call Cube Store. It does pre-aggregations, and they're all aggregate aware, which is kind of a handy feature if you're building a query rewrite engine. And finally, like I mentioned, API access is going to be important to any semantic layer. You really can't call yourself a universal semantic layer if you don't support all of the consumption patterns that your users are going to want to consume data with. Now, keep in mind, semantic layers are not the same thing as like an ORM, which might be used for more like CRUD operations in a web app. And it's much more focused on metrics and aggregations and analytical queries. So again, I assume that's what most people here are kind of thinking of when they think of data technology, but I always have to say that. Let's dig into query rewriting just a little bit, because it is kind of one of the core concepts that most semantic layers have to tackle in some way. This image here is an image of a cube query generated in our playground. You can take a look at the SQL in the editor here. It's relatively simple. We're just going to select state, city, and then where this gets a little bit funny is the measure function. So in Cube, we actually implement what we call a measure function that essentially defers aggregation down to the underlying rewrite. So it says, look, you can read this as this is an aggregation, but I don't have to tell you sum or average. Just let the rewrite handle it and then get me the result back. And in this case, we're going to pull average order value from what this is, a sales cube is what this is, from sales group by. So this looks like basic SQL. You can see that this is like a standard editor representation. This is a sales view in Cube. We're grabbing average order value. We're grabbing city, state. What this has to do to actually hit Snowflake in our data model is this quite ugly expanded query. If you kind of walk through this, you can see that we're doing some things like, okay, we have to do an upper and a split and kind of some, just like cleanup work on what is a sales state. We have to do a couple left joins. We have to do a subquery. You can see here that, to get that average order value, we've got to multiply quantity by price. So this is all defined in the data model ahead of time. And this is a relatively simple example, but this kind of idea of allowing the front end users, whether that's in a BI tool or whether that's in, an application, to write relatively simple SQL, but have that expanded out to this kind of ugly thing that goes back to the data warehouse, and all of the accompanying sort of dynamic fields or time fixes or other things you need to do in here. That's kind of one of the big ideas of what semantic layers do. So I think understanding query rewriting is sort of important to understand, like, why you would bother with all this. So what problems do semantic layers solve? Like, why do people buy these things? Like, what are we really going for here? As we've kind of talked about already, a lot of the big problems are just decoupling data modeling and metric logic from wherever your presentation is. Your presentation could be, embedded analytics. That could be, are you a B2B application, and do you need to display some kind of charting in the dashboard, right? Or in the app? Like, maybe you're in a logistics company and you need to show some visuals on like number of shipments, time intervals, how long they've taken, things like that. I mean, you can think of a lot of consoles or analytics portals inside the apps you deal with, right? Like, how do those things render charts? You could embed a BI tool. It's not the best experience. There are really good ways of doing this with things like Chart.js and React, frameworks, which are becoming really popular to do this. So that's what we mean when we say embedded analytics. BI tools, of course, we talked about earlier, being able to keep your numbers the same in a Power BI, in Tableau, in Excel. Obviously, representing the same business logic in each tool is a challenge. If you don't have something like a semantic layer to do this, then you're probably trying to keep calculated fields in sync in a Tableau data source file, in a Power BI semantic data model, and then good luck in your spreadsheets, right? And then, as we kind of hinted at earlier, really AI is giving this whole idea a lot of tailwind. We're going to talk about that more in depth. Additional sort of problems or sort of benefits that you get, this idea of modeling data once and delivering it to multiple destinations. That's one of the most sort of succinct ways to try to explain what a semantic layer does. Really, I just want to hammer that concept. The idea is shoving the semantics out of the BI tools and out of the presentation layers, and shoving them left in the stack into a consistent place that can do caching, inconsistent sort of time expectations for performance, consistent security and governance and multi-tenancy, security context, all those things. And then also consistent business logic. So yeah, I mean, single source of truth is sort of a meme, but this is moving in that direction, and it's something that we try to do. And finally, if you have a scenario where you need to do dynamic query writing and query building, maybe you have complicated date logic or complicated time intelligence, things like year to date, period over period, things like that. They're much easier in semantic layers. I like this section because this is the objection section. This is that stuff's cool, but why can't I just do it with something else? And the most common is, but you can do that with a database. Yeah, sure, you can do all this for simple things. Believe me, we've lived our lives without semantic layers. The things where this gets complicated for are doing ratios at different grains. The classic one is something like average revenue per user. Where maybe you need to do a subquery and then a distinct in there in one part of the subquery. If you've worked in insurance, per member per month is sort of a nightmare to calculate. Classical time intelligence things are quite difficult, or they're not impossible, but they're just annoying, right? Where you do year to date, trailing 12 months, period over period, custom calendars, these things. These are all just a headache, right? And sure, your BI tools have pretty good affordances for doing that, but that's because they're doing all of this in the background. They're sort of generating all of this ugly parameterized SQL. But what if you want to then shove that same number into a React app that your boss uses for some reason, or that you provide to your customers in your application? Or God forbid, you want to shove it into an Excel file and say, hey, the finance team can have Excel back and they can do their FP&A stuff. That's actually what you would have used SQL Server Analysis Services for, or Oracle Essbase for 20 years ago. But those products are becoming much harder to find. Things like dynamic security, logic, or filtering are much easier in a semantic layer because of the query rewriting capability. And then obviously multi-fact modeling. And the classic problem here is doing it in a way that you avoid Cartesian products, fan outs, chasm traps, all those obnoxious things that can happen to you. So this is a common one. I think a lot of people that say, yeah, this stuff's cool, but you know what, man, I'm just going to do it in a view in Snowflake. And give it a try. You can do a lot of it. You will eventually run into some things that are hard, and that you say, hey, it would be neat to have another layer in the middle that can do some dynamic SQL generation for me. You get the question a lot, yeah, but you can do that with a materialized view. Let's talk about performance here rather than just thinking about logic. A lot of materialized views do not have aggregate awareness. And if you're not familiar with the idea, when I say aggregate awareness, what I mean is, let's say I build that sales view in Snowflake, and maybe sales is actually several joins of order, line item, customer, product, maybe a calendar table. In Cube, we can define pre-aggregations on different grains on that view. And if a BI tool comes in and issues us a query over the SQL API, or anything issues us a query, we will automatically rewrite that query to serve it from the fastest pre-aggregation we have. What I mean by, aggregate awareness is you don't need to know that, hey, I need to hit the day aggregate, or I need to hit the by product aggregate, or I need to hit the, whatever. Nobody has to rewrite the where. part of their you know, their query to do that, or the tables they're selecting from. Snowflake is adding aggregate awareness, and I think they probably already have it to a high degree for materialized views. I don't know where BigQuery or Redshift are on this. Like, I would be surprised if Redshift ever gets this. I don't know if Databricks does it or not. So I'm going to call it limited capability. And then again, caching and pre-aggregations are really sort of a crazy concurrency superpower. If you are expected to serve metrics and reporting and dashboards to users via a web app, you suddenly inherit people's expectations about web performance. You're no longer sort of okay at, hey, my BI dashboard took 10 seconds to spin. People are thinking like, this app needs to load in like 200 milliseconds. So, you know, that's kind of the level of expectation you start to inherit at that point. Yeah, so I mean, you can do some of this with materialized views, but, you know, I would say, you know, can you do it for over 1,000 queries per second at 50 milliseconds? You know, with Cube, we have customers actually doing this at over 100,000 requests per second. So you hit 100,000 requests per second on Snowflake and tell me what your bill is. It's going to be a big number. Yeah, but you can do that with a BI tool. That's a very common one. You know, let's talk about the embedded angle. Embedding BI tools sucks. If you want to iframe Tableau, it's not a good experience. It's never been a good experience. You can ask me how I know. I was at Interworks. We sold more Tableau than like anybody on earth. So I made a lot of money embedding BI tools. It's not a good experience. Embedding Sigma is a little better. Embedding preset in Metabase, a little better. But generally, you know, if you want absolute control over look and feel and making the visuals the most integrated with your app, you're going to turn to something like a front-end framework in React and Chart.js. Like, that's where you're going to go. Also, I would say, do you only have one BI tool? You know, if you don't, again, like, how are you synchronizing those metric definitions? We find that a lot of, you know, upper end corporate to small enterprises have at least 3 to 5 BI tools running around. They've also got people using Excel. They've got people using Google Sheets. And we've seen a lot worse than that. I mean, seeing 10 is not uncommon. And, you know, I think about, as we all think about like where AI is going, a lot of the BI tools have AI offerings. Those add-ons are not great yet. So a lot of people are starting to building their own things and then realizing that, hey, we have to solve semantics, because if our humans that are trying to figure out this data, you know, don't understand what these metric definitions are, or how to use the correct one or the correct tables, then how do we really expect AI to do that any better? And I would also comment that right now it's quite fashionable for every BI tool to add a semantic layer, but the idea of universality, which we've been talking about, is in nobody's interest. In some ways, the universal semantic layer players, we're all, I guess, kind of cutting against the Snowflakes and the Databricks of the world and the Tableaus and the Salesforces of the world, because we're trying to build towards true interoperability, and help folks try to escape some amount of lock-in here. I've spoken for a while, so any questions? I'm going to take a drink here and get to the next slide. Okay. Yeah, the generic, you can do that with X plus Y plus Z. Yeah, I mean, of course you can. You can build your own platypus. It might look really crappy like this one that I got off ChatGPT. Let me know when you do build one. You know, write a blog post about it. I'll repost it on LinkedIn. So yeah, sure, you can slam Redis together with Fast API, with Type ORM. You know what, man? Live your life. Where did semantic layers come from? We actually did part of this. So thanks, Aaron, student of semantic layers. You knew where I was going to start. I would start with business objects and Cognos in the 90s. Where they kind of came from was this idea of more business-friendly abstractions of SQL. SQL was less common. It's really funny that this is where they started, because I think we always have this debate in data engineering. Should business users learn SQL? Should they be expected to learn SQL? We were having this debate in the 90s, in the 2000s, in the 2010s. That debate's not going away. Just like SQL is not going away, that debate is not going away. But that's where business objects and Cognos started. When you hear a business objects universe, that is a semantic layer. That is a very early representation of one. Finally, I think a lot about SSAS, multidimensional cubes in SQL Server analysis services, which have become Azure analysis services, which have become big parts of Fabric. That part of the product over there at Microsoft and Fabric is really never going to go away because it serves a lot of MDX, multidimensional expressions, DAX, data access expressions. These are like the cubing and cell level languages at Microsoft. Multidimensional analysis and aggregate cubing technology is sort of where that went. You started to see SSAS introduce caching to this, like pull all the data into the cube, process the cube, give Excel users all of their hierarchies, all of their roll-ups, all of their drill-throughs, all those things. I don't know what the makeup of this audience is. Maybe you were old enough to run into this stuff. I know I was. I started working on SSAS when I was younger. And yeah, Aaron says he started Business Objects 5.17 in 2007. So yeah, I got out of college in 2006 and I jumped right into data. So I was starting to see SSAS still quite prominently. I saw a lot of people use it. Probably the semantic layer that I would say the most folks that are kind of coming up in the modern data stack generation would have touched and used would be Looker. LookML is a semantic layer. And yeah, I would call it like a fairly major revival of the idea of a semantic layer in the cloud and aligned with cloud data warehouses. So, when we think about building Cube, all of these technologies for us are prior art. I mean, we're really looking at all of them and thinking about what they did and how we can kind of take their ideas, improve them for the future, and also meet users of today where they are with how they want to use data on the other side of this, right? Finally, you get to the 2020s. There's a few of us out there building these things. Our friends at DBT, they acquired a company called Transform with Metric Flow. They've been incorporating it into the product and as the DBT semantic layer. Again, I work for Cube, so we build one of these. There's a company called AtScale that's still out there. Really, if I had to redo this slide, I would have put AtScale somewhere between 2010s, 2020s. They've been around doing this a long time. But there are a lot of folks building semantic layers. There are not as many building universal ones. A lot of people now are trying to go from a place of saying, hey, I have a product and I need to add semantics and maybe I want to open it up. So that's kind of where Tableau has gone in Salesforce. Salesforce has a semantic layer underneath their data cloud objects, right? So if you actually take a look through how they're going to do semantics in Agentforce, that is a semantic layer product in there. Yeah, Snowflake has a semantic layer now with semantic views. Databricks has one with Unity catalog metrics. They just have varying degrees of sort of functionality. Why are we talking about semantic layers? That's a great question. I get this a lot, like, hey, where did semantic layers come from? And like, why do I see them everywhere? Well, I'm tempted to tell you because companies are building and marketing them. Like if you're on LinkedIn, like you talk about what people are marketing. So if you're talking about Cube, that means our marketing's done its job. I would say in a lot of ways, DBT put a lot of gas on this with their acquisition of Transform. They really did more marketing than I could have ever done at Cube. So I have to thank them for that. But the reasons you would need one are really not going away. So customers kind of keep finding them. I would tell you embedded customer facing analytics isn't going away. It's bad for the reasons I mentioned before. Just embedding a Tableau dashboard has a bad licensing model. It has bad performance. It has bad usability and bad look and feel. Embedding lots of BI tools have these same characteristics. Embedded Looker, for example, is incredibly expensive for what it really is. So folks really just want more like the data access, data modeling parts of a BI tool, like sheared off and then applied to really good APIs so they can just build whatever they want with a front-end software or front-end frameworks. I think we're in like this post-Tableau and post-Looker era where there's a lot of BI tool sprawl because there's no longer a single dominant BI player the way Tableau was in like the late 2010s. And so as you have this sort of sprawl era where there are more BI tools in each org, like this problem is probably getting worse and not getting better. Like we're not getting any closer to consolidation. Finally, CDW bills are growing everywhere. I don't even know how many startups there are at something like AWS reInvent or at Snowflake Summit or Databricks Summit that are just working on, hey, we can help you reduce your Snowflake bill. So caching starts to become really appealing. If you know that, hey, you're doing fairly predictable embedded analytics dashboards that can be highly parameterized, and you could just extract everything to something really fast. Now, you could also, go back to my, why don't you do this with X? Maybe the world will get to where like we're all just, spitting all this stuff out into DuckDB and doing it in WASM. I don't know. That might be the mother duck answer. You should ask Jacob Matson if that's the answer. Maybe he'll tell you it is. And finally, I would say AI tailwinds are kind of putting a lot of gas on semantics right now. I don't know what to call this category. You can call it AI BI. That's what the Databricks Genie version of this would be called. I put agentic analytics in question mark. That's actually what Cube's going with. We've seen some early Gartner work. That's what we think the category is going to get called. And generally, this idea is that AI BI without semantics has fairly notable accuracy problems. And it's, in my opinion, and the opinion of a lot of people building semantic layers, that this is not something that the LLMs are just going to power their way through, because that LLM is never going to be trained on a corpus of understanding that your individual business has a really screwed up data model because it did 8 M&As. And, it's trying to munch together something from like 3 different ERPs. That's not in there. So somebody's going to have to tell the software that at some point. And yeah, let's kind of keep going through here. I guess on time, I got about 20 minutes left. I'm pretty close to the end here, and I'll have room for some Q&A. Where semantic layers going? Yeah, I think where they're going is certainly like being used in AI. When you saw Snowflake throw their hat in this ring with semantic views, to a large degree, that was to make Cortex a better platform and to improve Cortex's accuracy. That's going to show itself in something like Snowflake Intelligence. When you saw Databricks do this with Unity Catalog metrics and metric views, same thing. I would call it the same thing for AI BI Genie and for Databricks One. That's my assessment. I don't work for those companies. I just do alliances at Cube. But yeah, I mean, you can see that really ever since we've been in what we would call like the Gen AI era, the Google trends on semantic layers have just been up and to the right. Yeah, so that's generally like I think where the ball is going and like why people care right now. And this is of course a wholesale Cube slide. You would see us present this, but yeah, the idea here is that with this idea of semantic SQL that we talked about earlier, which is the relatively simple SQL query of select dimension I need and measure I need from business entity. A semantic layer deterministically translating that into the gnarly actual full warehouse SQL that you need to run is something that lets us build AI agents and agentic analytics experiences or AI BI experiences with a lot more confidence. So finally, maybe the thing you came to this talk asking yourself, do I need a semantic layer? Should I buy one of these things? Should I get an open source one? Should I start learning about them? Well, it's a trick question. You're already using semantic layers. As I mentioned before, every BI tool that has a connection dialog, calc fields, data sets, those are semantic layers. If you interact with Tableau, if you interact with Preset, if you interact with Looker, Metabase, and you connect to Postgres, and then you define some calculated fields, or maybe define a case statement or something like that, that's semantics. I mean, you're already doing that. The real question is probably, do you need to invest in a universal semantic layer? Sure, we could talk about that. Yeah, as I mentioned before, Snowflake and Databricks have really been going down this road to improve their AI BI offerings. I won't be surprised to see more companies start to do this. I mean, you've already seen Microsoft has started to make more of a deal of tying what they're doing in Power BI into a semantic data model. They renamed their connections and data sets to a semantic data model. Every day I see somebody else who's like, oh, we're gonna add a semantic layer to our product and we're gonna open it up. And I wish them good luck because it's not easy. So maybe the real question is, do you need a universal semantic layer? I generally think that there's a couple eval criterias here. Like I said, I don't carry a sales number. I'm not going to tell you all that everybody needs one. Do you have complex metrics and you need dynamic query rewrites? Do you have complex ratios? Like, do you need to do something really ugly that you're tempted to, I hate this phrase, but boil the ocean and pre-calculate everything in a really ugly way? Yeah, that's a problem a semantic layer can help you with. Are you building embedded analytics into your product? And do you want caching, multi-tenancy, security contexts, and really all of like the ugly data processing stuff to live somewhere? And then you just call an API and you render your charts. Like, yeah, semantic layers are great for that. At least the ones that have REST and GraphQL endpoints and are built for that use case. Do you still have multi-dimensional or OLAP use cases that require complex things like XIRR? This is why SSAS and SBase and these cubing platforms have been like endemic in finance. You will still find a lot of FP&A orgs that are using that are still using these platforms. And modern semantic layers solve a lot of the same use cases. They just do it in a different way. Are you building AI analytics experience that interacts with a database? And do you want to let users define their metrics and then give the AI, whether that's any model, whether that's LangGraph or LangChain, and however you're building your app, do you want them to have a better handle on querying a metric? Yeah, I mean, a semantic layer can help with that as well. Generally, I think a really good test is like, do you have complexity? And as I mentioned before, do you have several BI tools? Do you have several databases, several data warehouses? Do you have a really wide range of constituents and users? I'll tell you flat out, the 50-person company that is just doing BI for the first time, like, they do not need a universal semantic layer. That company would be very happy with a Snowflake or a Databricks or whatever, probably Snowflake, and snagging like a Sigma, Hex, and Omni. Like, those are great products. You should use one of them. If you're 20,000 people and the org has been built over many years of decisions you didn't make, and you're trying to dig yourself out of a weird place, that's what the average semantic layer customer looks like. That's what I've got for you guys. Yeah, so what now? Yeah, I mean, if you want to learn more about this topic, cube.dev is where you can find us. I would check out our docs, our blogs, videos, tutorials. There's a lot of stuff there. In the interest of neutrality, Snowflake has produced material on semantic layers. Go look up their semantic views, how they're interacted with in Cortex. Databricks, same thing. Unique catalog metrics. DBT makes a semantic layer. AtScale makes one. They have great materials. You can email me directly. I'm Brian Bickell at cube.dev. I'm on LinkedIn. Yeah, I mean, that's kind of it. So happy to answer any questions. I can hang out for another 10, 20 minutes. Yeah.
Ronaldo, you have a question?
Yeah, go for it, Ronald.
Yeah, Brian, thank you for the presentation. So one question, you mentioned about analysis services, right? So analysis services started as using disk, and later we had the tabular mode that was doing that in memory. So, but one of the limitations is depending on how big it is your semantic model, you are not able to run that, right? Because it's going to consume a lot of memory.
Right, because Vertipack, the engine in that product, scales on a single node basis, right?
Yeah, and how that works for Cube?
Good question. Our caching technology, as I mentioned, is called Cube Store. It's built on Apache Data Fusion in Rust. It is a hybrid in memory and in disk in Parquet on cloud object storage. It actually scales indefinitely horizontally. So we have incredible scalability on that product.
Nice, thank you.
Yeah, Vertipack's a really interesting engine. If you haven't looked up like that material and like looked at the early analysis services stuff, it's an incredible product. So
yeah,
it's funny that it's out of favor now, I mean, because it's a really cool product.
Yeah, they have added that also to Power BI, right? So the background make use of that.
Yeah. Any plans for a Flink source? Ooh, okay. I do not represent product, so let me say any plans for. We already do KSQL DB. I have not investigated Flink, but that's to say, you know, if it speaks SQL and if we can figure out how to get data out of it, then probably. Yeah, I like I said, it's not an active development, but could we build it? Yeah, I mean, a lot of those data sources that I support, we've built, you know, on a contract basis. So it doesn't sound impossible to me. Cool. If you got any other questions, like I said, happy to stick around. Also, you know, there are a lot of webinars that I've done on the Cube website. So, you know, if any of this is interesting to you, go check out the resources page there. Go watch the VODs. I think there's one next week about like our query caching performance and our benchmarks against popular CDWs. So, you know, if you got a situation where you pay a fortune on BigQuery slots and you don't want to, Cube can get you out of that. Believe me. Yeah.
Super cool. Well, thanks, Brian. I'm going to stop recording here. Well, there's one more question, actually.
Okay.
In the chat here from Ryan. He says, dumb question, maybe. Difference between DBT and Cube. Same goal of a universal semantic layer, or do they have solve different things?
Man, comparisons are hard because I have a lot of respect for everybody. But from the outside looking in at where DBT is at, I don't think they care that much about that semantic layer product anymore. Is my take. Pace of evolution and kind of like what they're doing over there doesn't look so fast. And I think they've got their hands full with a lot of the other problems in the platform. So I don't know. Where I think we compete with them right now, they don't have a dedicated caching engine like we do. When they do caching, it's going to be a materialized view somewhere. I think their security and query rewriting capability is a lot less robust. The number of databases they support is much less robust. And comparing semantic layers is a little bit difficult because there's this nebulous like idea of expressiveness. You know, again, like I mentioned, you know, we can do time intelligence and things like XIRR, which is quite complicated. You sort of have to look at each semantic layer and say, hey, can it actually represent the concept you're trying to represent? And there are differences. There are places where, you know, they're just not there yet. And we see this actually with Snowflake and Databricks as well. Like the difficulty in doing some translation between Cube and those platforms it's actually kind of lossy, right? Like we can represent or express some things in our language that they can't. So this is also like one of the open problems in semantic layers. Like how do you port semantic layers like one to each other? That's my take on DBT right now. I mean, I'll just give you guys an anecdote. Cube was banned from Coalesce last year on competitive grounds. Like I couldn't get a spot. I can get a spot this year, and Cube will be exhibiting at Coalesce. So whatever has changed at DBT, like either you know they had a change of heart or like that's just not a priority. I don't know which one it is, but I will be there in October. So come track me down and ask me questions. And Joe knows this story because like, yeah, I was there last year, but I couldn't exhibit.
Yeah, I think that you were among a few people who were kind of hanging out in the periphery.
Well, me and some very popular band people like my friends at Bickell. They were hard banned. They could not come in the show. I could